But good afternoon, everybody. I am Jérôme Girard, and I am the founder of InnoIT Consulting. And first of all, we hope you are safe and also your family as well. InnoIT is an IT and digital consulting company with a disruptive position in the market. Our goal is to know the best IT talent in Spain in order to manage their career path and to give them the best advices for the professional career. And we work with our consultant as a football scout does with a football player, or as an agent does with movies actors. We launched a company 9 years ago in France and 3 years ago in Spain. We are now a team of 250 people all around the world, and actually we are 45 in Spain. Today we are very happy to be here. We had more than 100 people attending the webinar. We have people attending from Barcelona, from Madrid, Mallorca, and also from UK and Argentina. As you know, today we are going to speak about DevOps and DevOps metrics. And I'm very glad to present our speakers. Gaston Fournier from Glovo. Gaston is a software engineer with more than 10 years experience in the industry. He really loves getting to the root of problems and understanding how things work. He also loves sharing and exchanging ideas and experiences with others. On the other hand, we have Jorge Arco from Codify. Jorge has more than 9 years experience in the industry. He is currently lead system administrator at Codify. He also has worked as a backend developer and as a team leader. He is interested in distributed systems, domain-driven design, deep learning, and observability. Today, I want to give a special thanks to Gianluca Rosania to make this event possible. Gianluca is lead recruiter in Glovo, and he is also the founder of Lyft. We will have a 1 hour, 15 minutes webinar, because with 2 presentations of 20 minutes, we think we will need something more than 1 hour. At the end of each presentation, you will have the opportunity to make a question to each speaker. Please write your question on Zoom, on the wall, preguntas y respuestas. It will be better than on the chat. Now, I will let Gianluca present you to Lyft. And thank you very much again for being here, and enjoy the webinar.
Thank you, Jérôme, Jorge, and Gaston. My name is Gianluca, as Jérôme said. I'm the co-founder of Lyft. Lyft is basically an educational tech recruitment company which tries to help to all the industry, because as a recruiter, I have seen many times that many recruiters are not here and able to speak tech with all the engineers and product managers and all those type of profiles. So the objective of Lyft is to try to educate and help as many people as we can. And today we have 2 great panelists that are going to add a lot of value in Jorge and Gaston. So nothing else, I leave you with the masters. Enjoy.
Okay, thank you, Gianluca. So let me start presenting my screen here. Okay, can you see it correctly? Jorge, yes?
Todo okay.
Perfect. So as Jérôme mentioned, I'm a backend engineer. I don't have a strong LiveOps background, but yet I like diving deep into different topics. While monitoring latency here at Glovo, we learned a lot of stuff, and well, basically I wanted to share a little bit with you. So let me get started. This is more or less the agenda that I'm going to cover. Okay. So first, I'm going to start talking a little bit why is it important to monitor latency. Then a little bit of how we monitor latency at Glovo. some things that we learn along the way, things that went well, things that went wrong, and some advices or things that you can implement to do it better. So first of all, why is it important? Well, if you read Google's System Reliability Engineering book, it's listed as one of the 4 golden signals to look into. And it can save you money and boost your business, as I will show later. But it can also help preventing major outages, because when you have a latency increase, sometimes it shows that there is some other problem in your system. And even with all of these reasons, sometimes measuring latency is not given the importance it has. And I believe that in part that's because we don't fully understand how monitoring latency works. So to have a little bit of history, this is from 15 years ago. Marisa Mayer was a VP at Google, and she shows some numbers. I'm going to go a little bit quick with these ones. But basically, increased latency can lead to reduced traffic or even a reduction in sales. And this is a newer report from Akamai, and they are also finding more or less the same situation, that when you have a site that responds slow, then your customers are leaving the site earlier. They don't convert as much as if your site is faster. And that's why basically, if we want to boost our business, we need to focus in having low latencies. So these numbers that are from 15 years ago, I don't want to imagine how much this will impact today. So how we monitor latency? We are using Datadog as our monitoring platform, and we use Terraform to declare our monitors. We use it to create and modify our monitors, and it allows us to have templates. We use it also for errors, but basically having these templates allowed all our engineers to easily extend and to have coverage of these golden signals on most of our endpoints. I'm not going to say that we have everything covered, but we have a lot of them covered. We try to monitor everything, but we also care about the on-call noise, and we try to only bother the on-call when they have something to do with the alarm. Otherwise, it's just noise and it doesn't help anyone. And most of our latency monitors are using P50 or P90 metrics. And you may ask why we don't use averages. And basically, averages is not a good metric for measuring latency, because you can have 2 requests, for example, one with 10 milliseconds, another one with 100 milliseconds, and the average will be 55, which doesn't represent none of the customers. So basically, it doesn't represent your customers, and that's why percentiles is preferred over averages. And with all of this, we had a standardized way of measuring latency, and we reduce the trouble of defining what to measure or how to measure latency. So to explain, if you don't know what is P90 latency, I'm just taking P90 just to take something, but basically it works for all percentiles. So P90 basically is a value that splits all your samples in 90% and 10%. If you had 50%, then it splits the sample set in 2. But if you start measuring latency, most of the times you will have this kind of curve that it's a normal curve, and then you can calculate easily the 90th percentile. So what does it mean in terms of samples? So here I have some 50 samples in a time window that you can, I'm not speaking here about the time window, these are just 50 samples. And if you can see, if you have 50 samples, then 10% of the samples that you have to leave on the other side are 5. And if you can see here, there are 1, 2, 3, 4, and 5 samples. So if your latency looks more or less like this, then it means that you will have some outliers that can go even higher, but you are not counting them. And that's kind of the purpose of the percentiles, that you don't take into account the outliers. So if I can show you this a little bit with numbers, if you are taking 10 samples, then it means that you are leaving outside only one value. But if you take 20 samples, then it means that you can have 2 outliers. Here I have the value of the percentile, take into account that this is done with spreadsheet and they are doing this interpolation between some values. But in most of the cases and most of the tools, they just take one value which is in your sample set. So in this case, it could be 182. But well, this is how spreadsheets calculate this. And here is the link to this spreadsheet. If you want to go and play around, just feel free to do that. So I'm going to use that example to explain more or less how alarms work and what went wrong with from our experience. So for example, if you have these 10 samples and you have one outlier of 2 seconds, if you set your threshold to go off at 400 milliseconds, and I pick these numbers just because of spreadsheet doing this interpolation, but it could have been 195 or 200. But for this example, in this case, the alarm wouldn't go off because the P90 that we calculate with these 10 samples is below 400 milliseconds. But if we have a second sample that is higher, or a second outlier, it means that our P90 will grow up to 1,900. Eventually, the 10 is added by spreadsheet. And in this case, the alarm will go off because this calculated value is above our threshold. And what can we do with this? As if you pay attention to the previous slide, if we take into account more samples, okay, it means that we can have more outliers that are not going to be considered when calculating the P90. So if we can have 20 samples instead of 10, and actually these are outliers, our normality is that we are below 200 milliseconds, then we are again okay, and this alarm won't go off. So why is this important? Well, if you are having a fixed threshold, then maybe when you have low traffic, as in this case, the latency can go a little bit high, okay? So one thing that you can do in this situation is increase the time period. So this 20 samples comes from, I don't know, in this case, we have 24 hits in 20 minutes, and this value is calculated with these 24 hits in a 20 minutes window. So if you can increase this to 40 minutes or 60 minutes, then it means that you will have more samples. And with more samples, as I showed, the P90 value, which is this yellow line, will be slower and smoother. And in that case, you can have a healthier on-call. But it may take longer to realize that you have a problem if you are in the peak hours, because it means that those outliers, you will have to have much more outliers in order for this alarm to go off. So that's something that went wrong for us. We had some low traffic endpoints that we had to tune a little bit. And another thing is that maybe your normality is that more than 10% of your requests have anomalous latencies. And it can be because of, I don't know, something in your application. Maybe if you have anonymous requests and some non-anonymous requests, the anonymous one may take fewer time to process. And in this case, maybe what you can do is just consider having using a different percentile. For example, if you use P75, it means that with 10 samples, you can have up to 3 outliers. And in that case, you will prevent the alarm to go off too often. But also take into account that with this, you are ignoring 25% of your request. So if you, instead of having 10 samples in the time window that you define, you have 10,000 samples, then it means that you will have more than 2,000 requests before the alarm can go off. Another thing that you can do is to increase the threshold. This is something that we did, but sometimes you have these situations and you don't want to set the threshold at 2.5 seconds, because if you have an increase from 400 milliseconds to 2 seconds, it will be okay, and your alarm will never go off. So that's more or less the things that we learned through our journey. And you know, things were not perfect, but we raised the awareness of latency as a key metric. We tried to force everyone to have them. We developed a process of continuous improvement with sharing as a key factor. So we iterate on the alarms and try to improve them to reduce the noise. Almost all of our endpoints have error and latency thresholds, and we managed to have a healthy on-call rotation. Whenever something is wrong, we try to improve and reduce the noise. And with this, we created a culture where all of our engineers care about our metrics. So things that from my side, or as a takeaway for you, things that we learn. First, there are always alternatives to deal with overly sensitive monitors, and we discussed some of them, like increasing the time span where you are taking the samples, increasing the threshold, or using a different percentile. But you should not fall in the excuse of this monitor is overly sensitive or doesn't work well, let's remove it. We did that in some cases, and we face problems later. Always keep track of your latency, and maybe use a combination of P50 and P90. You know, P50 can work better for short-term, for the short term if you have fewer samples, and P90 you need to have more samples to make it more stable, and use proper time spans. So in order to do this and to properly configure your alarms, you need to understand your traffic patterns. And you have to play with different percentiles and time windows and answer 2 questions. First, how much traffic you have at peak time and off-peak hours. And if you pick one percentile, how many requests that represents. Because you have to always take into account that you are affecting customers with your decisions, and this is really important. There are some discussions around what is the right sample size. Some mathematicians and statistic engineers say that 30. In my opinion, or from my experience, with less than 100 samples and measuring latency, things can get too noisy at times. So I prefer to have 100 samples at least, in order to configure the alarm. So adapting to traffic patterns, this is kind of an alternative solution that we also tried. You can just ignore off-peak hours, like having an alarm that will only go off on peak hours. Maybe this is not great, and you may have some deployment at low peak, low traffic hours, and you won't find out that something is wrong. Another thing that you can do is to combine traffic alerts with latency. So latency won't go off if traffic is below the threshold. This is somehow a way of automatizing the previous point. And we did that for some teams, and it worked more or less well, reducing the noise, but then you also have to manually review your dashboards to see if there was something anomalous during those times when the alarm is not configured to go off. or you can have both solutions and have two sets of alarms, one that is activated on high traffic and another one that's activated in low traffic. In our case, Datadog allows us to do that, but it will depend on the solution that you're using. Or another thing that you can do, and for this I invite you to stay for Jorge's talk, is use more advanced techniques like anomaly detection. If you are interested, I highly recommend to stay tuned for Jorge's talk. I heard it and it's quite interesting. But that's another way if you have different latency that change with traffic, maybe that's another way of handling these situations to avoid the noise. So rounding up, because we don't have a lot of time, here is a list of resources that probably Jerome is going to share later. But basically, I recommend the Google Site Reliability Engineer if you are, especially if you are in the LiveOps area. And then there are a couple of blog posts and different stuff. The last two are really good about why not using averages. And yeah, feel free to read them and reach out to me if you have questions or anything. And I think with that, I conclude my talk, and I'm right in time for Q&A. Right, Jerome?
Thank you, Gaston. Yes, we have a few questions for you. Okay. Regarding Datadog. How much costs Datadog? Yeah, and did you consider some alternative?
I don't know how much it costs. It was a platform decision. We analyzed some different tools. I know that we analyzed New Relic. We also thought about using our own monitoring platform by using some open source tools like Jorge will show now, I think. But we wanted to have like a handoff solution. We didn't want to maintain anything, and that's why we choose one solution as a service. But about the cost, I'm not sure. I'm not the one paying.
Don't worry. For the moment, there is no more question. So perhaps more question from some new question will come to you, Gaston, at the end of the speech. So let's speak Jorge now. One last question for you, Gaston. Have you ever considered using Grafana?
Yeah, that's another alternative that we consider, but as far as I know, it doesn't provide a solution, a SaaS solution. So you have to install it yourself and maintain it, and that's something that we didn't want to do at Glovo. So yeah, we consider, but we felt that it wasn't the best solution for us.
Thank you, Gaston. You're welcome, Jorge.
We cannot hear you, Jorge. No.
Jorge, no va. Ahora sí.
Does it work now?
Ya te tenemos. Bienvenido.
Nice. There is nothing like disconnect and reconnect. Okay, so let me share the screen. Thank you, Gianluca, for the presentation. It's really interesting because there are some things you have talked about that I'm going to be talking also. First, this anomaly detection with Prometheus. So keep in mind that I will be talking about and showing a few things that are Prometheus specific. So I have links on resources at the end of the talk that I will share with the ones that are interested. We are going to be sharing all these slides later. So if you have questions or whatever, there are resources to have a look. So let's go for it. Anomaly detection with Prometheus. So this is me. I'm Jorge. I'm the head of sysadmin at Codify. And here is my GitHub account if you want to have a look at it. Our stack. We are in AWS. We have a self-hosted Kubernetes cluster in EC2. And we use Prometheus operator to orchestrate all the monitoring for the metrics for our application. It's a bit more complicated than this because our company has 7+ years since started. So we have some legacy tools that requires other things like an StatsD server and things like that, but we have managed to have an exporter to Prometheus to centralize everything there. Because of how expensive Prometheus can be storing long-term metrics, we decided to use Thanos to be able to have higher retention span, like having metrics for the last month, 6 months, 1 year, 10 years, whatever. And on top of that, we use Grafana to display this information. The reason why we went that path is because we were in Datadog, and answering the previous question, Datadog is quite cheap, to be honest, for host monitoring and also application monitoring. But there is a problem when you have custom metrics. And the reason is that they charge $5 per 100 unique metrics. And that means that if you have one metric with 5 labels, you have to multiply by 5 for each combination of it. So you can easily go from 400 metrics to 60,000 metrics by just adding the country from where the user was accessing from to a metric. So it was a risk, and we decided to build our own to prevent surprise at the end of the month. So to give you some context, where we are at Codify. Codify is in the adult industry. So looking at the right side, you can see that we have some sites that are some of them quite famous. We have an important volume of traffic, and we have also a really clear seasonality behavior in the traffic. Because of the adult industry, we have also an important number of attacks, especially during this quarantine. And some things that we have done in the past to react to mitigate this is to react faster to these attacks and also to possible mistakes. So what happened here is that we got one problem when we build all of this, and is what basically that we want to automatically detect anomalies in our traffic. It sounds quite easy at the beginning. When you get the ticket, it's like, okay, I will take basically the average over a week and compare with the last 5 minutes or 10 minutes and see how it goes. But unfortunately, there are some caveats you have to take in consideration. This is the traffic of one of our sites, and you can see that these big spikes in the traffic are really short time spans of 15, 20 minutes are not anomalies, are expected behaviors. And these are some examples of it, but there are others that are even bigger than this. So the traffic fluctuation makes this average to be completely out of the scope for this kind of spikes. Also, we have heavy marketing campaigns that can trigger a low traffic alert when they finish. If we have an alert, if we have a marketing campaign this week, I don't want to have an alert next week because it had stopped and the traffic has decreased. the average is still high, and we have this low alert traffic alert, and we want to avoid this. And so to have this the thing in consideration, we will need to basically compare with previous weeks, month, or previous months to compare the traffic against it and learn from the behavior of our traffic. The cool thing here is that you can see the traffic is quite stable and follows a easy to see and understand pattern. So it indicates that it's a normal distribution. So let's address the problem. I will go quite fast here. As Gaston has explained here, this graph is showing density curve, which is basically the line on top of this normal distribution graph. This line indicates how density is this point in our metrics. It means that the closer it is to the average, which is the point in the middle, you will see more points than in the extremes of the curve. So this is quite helpful, especially with the cscore function. The cscore is basically measure the number of standard deviations from the mean. You can assume that any value that falls outside the range of plus minus 3 is an anomaly. And it's an anomaly because it represents something outside the 99% of the normal traffic. So if you have a look at the bottom, you will see that there are some numbers like 3 to 1, and then plus 1, 2, 3, and 4. These are the standard deviation from the mean. With this formula in mind, don't worry if you don't get it. There are resources at the end of the slide, so you can go there and have a read, and also in Gaston's slides. So we have to take a few things in consideration. The first one is the long-term metrics. Because we need to compare with previous months, we need to do some calculations in order to avoid expensive queries. And to that, we need to aggregate metrics. By aggregating these metrics, we are going to calculate the value for a given time in the past. And we can also discard useless labels that we don't care for this particular metric, okay? This will allow us to consume less resources in Prometheus and also have way less storage in S3 at the end of the day, which is money. Another thing that we have to talk about is that we use traffic as ingress controller. So all traffic that came from the outside passed through the ingress. So by monitoring the metrics for the ingress, we can basically have this calculation done for every URL or domain that we have in our platform. So for our example, we are going to be excluding all labels except backend and aggregate by 5 minutes. Why 5 minutes? Because of in the previous slide, these anomalies that you saw are quite fast change and increase in the traffic, and we need to react quite fast to this, because when that happens, we scale super fast in order to absorb that hit. And a little point here is that a backend in Prometheus label are, for example, the domain that we are going to filter by, like bucket.coms in the public area or in the members area, okay? As some of you already know. So this is how you create records in Prometheus. It's basically, we are going to be generating 4 here. The first one is the total traffic summed by the rate per second over the last 5 minutes. Okay, so we are going to take the traffic metric for the total request, and we are going to be rating by second and aggregating by backend. It means that you can ask for this metric for a particular domain, like give me what is the traffic, the rate per second for the last 5 minutes for the or per 5 minutes for black or vixen or different, so you can filter. And then we're going to do the same to calculate the standard deviation over 1 week, the average over 1 week, and we're going to use the following formula to calculate the cscore, which is basically taking the current traffic minus the average or the mean, and then we're going to be dividing this by the standard deviation over a week. So that's how the cscore function is, and let's see the results. And we have this. The one up top is basically the composition of the previous metrics. So in the blue line, you will see the traffic, okay, by 5 minutes periods. And the green line is the average. The one at the bottom is the standard deviation that, as you see, is quite stable. What's the problem? The problem is that at the bottom, we see the cscore formula. And as we have said before, everything that goes up or down 3 for the cscore is an anomaly because it's outside the 99% of the request. And you can see here for a time span of something like 2 weeks or a month, we have like a lot of them that are expected and are not anomalies per se. So we need to address this problem. To address this, we are going to be taking in consideration the seasonality. The seasonality is basically calculated by taking in consideration the previous weeks. So by taking in consideration the previous week, we are going to consider to generate a growth trend, in our case, per week. And we are going to do this calculation later with this. So the growth trends, basically the subtracting the rolling over week average for the last week from the rolling 1 week average for now. Take 5 minute frames from this week and the previous one to generate a prediction. So we are going to be comparing the traffic that we have now with the previous week and generate an estimation for what we expect at this point given the previous week, okay? But if we take the previous 2 weeks or 3 weeks before, we are going to be generating a more accurate prediction for the traffic that we expect in a particular moment. There are a few things that we have to consider here is that you will need to play, as Gaston said in his previous talk, with the timeframes, because depend of how stable is your traffic or your metric, because this applies not only to the traffic, you will need to consider 10 minutes, 1 hour, it depends. So, as I said, it depends how variable it is. So let's have a look and see how it looks. So that looks quite better. We have now the traffic with the robust trend for the last 3 weeks. You can see in the labels at the bottom that there is a label called offset that it displays which metric, which week is this metric for. And we can see here this approximation is quite similar and it's quite stable between the last 3 weeks. There are some points in the middle, like between the 6.2 and 6.4 that behaves quite differently, but in general it's quite stable. So let's have a look at the seasonality taking 1 hour time span. So if we take 1 hour time span, going back to the previous talk from Gaston, your calculation for big anomalies will be a really smooth curve that is longer in time span than it should. And it's exactly what it indicates here. Because of our traffic increase dramatically 2 times in a row in a period of 1-2 minutes, and then decrease first slowly and then goes up super high and decrease super fast. This needs shorter time spans in order to get a prediction more accurate to the real use case. Okay. This, for example, for other kind of business where the traffic is way more stable, having 1 hour, it should be more than enough, and it will be cheaper in terms of storage. So we have seen here that with 1 hour, this doesn't work very well. So we are going to try with 5 minutes, and with 5 minutes, it looks way better. And oh mama, we have here the median for the last 3 for the last 3 weeks for the prediction that we calculate from then, and we can see that we are very close to a normal day. So this, by doing this, you can do the comparison for what you expect and what you get in a normal day or during an anomaly. So we can say that the algorithm is now validated and continue then. Alerting. We are going to generate some alerts here. Okay, so the first one will be basically generating this prediction. As we have generated here, you can see at the top there is a really big calculation here. We are going to generate a custom metric in Prometheus in order to have a short one and don't have a massive calculation here, so it's easier to read. And we are going to take the traffic, minus the prediction, and take the standard deviation over the last week. And this give us the correct time. Sorry, the correct cscore. One thing that is important is that when we generate the alert, we are going to take in consideration the absolute value, because it can be positive or negative, depending if the traffic is going down or up. And another thing that is very important is that it doesn't need to be symmetric. You can have an alert for a standard deviation, which will be basically 99.999999% for the traffic when it goes higher. And when the traffic goes down, you can have something like a 2 for the standard deviation that will be more or less like a 70. And it should be fine, because you want to be more sensible when the traffic goes down than when it goes up. In our case, for example, we heavily depend of ads, and when the traffic goes down, it's an indicator that some ads can be misconfigured. So this helps us a lot. And last but not last, one of the most important things is to present this information properly. So with Grafana, there are really cool things that you can do to present the information. Here, what we did basically, we take the robust trend and we multiply by 3 standard deviations. So we have this purple line on top, and we do the same but multiplying by -2. So we have the purple line at the bottom. We fill up to the small one, the lower one, and we will see this line here in purple, which is basically the margin where everything outside this will be an anomaly. Then we have our value, which is the current traffic in green, and the robust trend generated in yellow. You can see that for some periods of time, you can have a small moments of anomaly, like at 8:35 more or less, that we got a small anomaly there. Something normal, because the time spans can go a bit upfront, so you have to be a bit flexible with it, but it will be very accurate most of the time. So things to have in consideration. Long-term store and retention in Prometheus could be very expensive. Okay, we are using Thanos, which help us to keep our metrics under control and in terms of storage. So we have the ruler, which is basically a piece that a component that takes some rules that the same that we have generated for Prometheus, but we will run into the ruler. By that way, we can decrease the Prometheus retention from 3 weeks or a month to 2-3 days of retentions in the Prometheus instance, and move the other to S3. And the compact will basically cook these metrics to have longer storage and do things like for metrics that are higher than a week, we'll do a compactation of 5 minutes, 10 or 1 hour for everything that is longer than a month. So it decreased heavily the storage in S3, in our case, S3. So as I mentioned, 2 or 3 days of retention in Prometheus is enough, even if you move the alert to the, even if you, if enough, if you move the alert to the rule component, and it saves you a huge amount of memory. Because how Prometheus work, when you ask for a calculation over 1 week, it will be a very expensive query. So you have to be very careful with this kind of calculations there. And the ruler component, as I mentioned, it has some caveats. It's heavily dependent from the network, which is something that Prometheus don't, because it has the time CDDB in a volume, so it has direct access to it. So if you have a network issue, like a very frequent DNS issue in Kubernetes, you might have a problem with the metrics also, and start firing tons of alerts that you should not be firing, and also heavily relies on the storage gateway, which is the component that talks with S3 to retrieve the metrics from it. And as I said, this ruler component might not fit in all cases, but when it fits, it does the job very well. So here I have some resources. The first two are basically the Prometheus site and the Thanos one. And the third one is how GitLab use Prometheus for anomaly detection. It's quite similar to this one, and it was super helpful and super well explained how they do things there. I really recommend to go and have a look at it. And the last one is a really interesting one about moving the cscore and play with this kind of seasonality stuff. And that's it. I went a bit too fast, but I think it was more or less super clear.
Thank you, Jorge. Questions? So feel free, Gaston and Jorge, to answer them. Why, I think it's for Jorge, why you set -2 on +3 as outlier? Can you read it, Jorge? I'm not DevOps expert.
Yeah, 1 second. We need to maybe stop or go to another place to read it. Yeah, here. Yeah, it's quite common. I mean, it's said why I said -2 and +3 as outlier threshold. In statistics, it's quite common to have it equally. And the reason is that this is for a business metric in reality, and you want to be more sensitive in certain scenarios than other. In our case, as we have a lot of attacks and also marketing fires a lot of campaigns quite often, when the traffic goes up, we scale up and it's not a big problem. But when we go down, it's critical because we heavily rely on ads for certain sites, and having a 20% decrease on the traffic is way worse than having like a % in the traffic, that can maybe scale down, because we can lose a lot of money in this scenario. So that's the reason why it's not symmetric. It's basically a business decision. But yeah, in statistics, it's quite common to have it symmetrical. And we have another question from Marcos. Are these anomalies usually indicate indicative of attacks? Did you use any anomaly automation to mitigate these possible attacks? The ones that you see here in like this one, no, these one are not attacks. These are releases. It's basically when we release a new video always at the same time. So at 7:30 almost every day we have a new video, and these spikes are normal traffic. So if it's a super famous actor or actress, it can go up to 100 times the traffic we usually go for a particular site. So the deviation is huge. But there are other cases where you can see that it goes extremely high and normal. And yeah, you can use exactly this to identify when there is an attack. And in fact, when there is an attack, it's way stable. And following the robust trend, you can see that even if the attack doesn't trigger an alert because it's not 3 times the standard deviation, because we sometimes have an attack to the join form with a dictionary or something like that, and it doesn't particularly trigger an alert for this endpoint, but we have another metrics for this one. You can see that the behavior is way difficult than the robust trend, which is the yellow line here. So yeah, you can use this to identify an attack. But as I said, when you have an attack, you really know you have it, because in this business, when someone attacks you, that's really hard.
So if I can add up something on top of Jorge, I totally agree with what he said about the business. These metrics and the alarms that you want to set highly relate with your business, and you have to understand your business. You have to understand your traffic patterns, your latency, and that's the best way of configuring alarms and correctly. And that's time that you have to spend, like understanding what is your business and what is good for you. There's no silver bullet for this.
Yeah, exactly. So thank you so much. And that was all from my side.
Any last question? I don't think so. Okay, Gaston, Jorge, thank you very much. Gianluca, thank you.
Thank you.
Also, see you soon quickly, and have a nice summer.
Thank you, Jerome.
Bye, team.
Lucas, thank you, Jorge. Really nice talk, and thank you everyone for attending.
Bye-bye.
Bye.